What if a perfectly patched industrial machine can still harbor unknown vulnerabilities where no one is looking? What if the technology that drives these industrial machines is not limited to automation tasks, but actually allows self-propagating malware to hide in the logic? Industrial programmable machines such as robots are used in many sectors, including automotive, avionics, pharmaceutical, and food production. They are very flexible and can perform many different tasks. Here we see 3 robots in normal operation doing a pick-and-place task. This software is a simulator used to write production automation scripts. These automation scripts are the core of a robot's logic and are usually written by automation engineers and system integrators. In this demonstration, all the software running on the robots, such as the operating system, is patched and free from any bugs. On top of the traditional software stack, all robots perform their task by continuously running an automation script that listens for commands from the factory network. The script does not perform validation on the received commands because it trusts the data that comes from the factory network. We found cases similar to this script on public code repositories, and of course we reported them. Also, based on the conversations within the most active online communities for automation engineers, it seems that they are not very concerned about the potential security risks in the automation scripts they write. Fortunately, only the first robot on the left is within the reach of a potential attacker on the network. The others are connected only to the first one via a local-only isolated network. Short of vulnerabilities in the regular software stack, the attacker in our demonstration tries to exploit the lack of data validation in the automation script. Now, the first robot is no longer running the original automation script. It's running a modified version that the attacker has uploaded by exploiting the lack of validation. The attacker can now try to interfere with normal operation, for example by injecting code that sends signals at unexpected times. The attacker may also be a bit more creative and make the compromised robot dance. Or they may use the robot to scan the isolated network for other vulnerable targets. And finally send a propagation command to the malware that they have written in this custom language, thus infecting the other robots. These issues do not arise from specific vulnerabilities in the vendor supply software, for which the vendors normally provide timely patches. We analyzed the 8 leading platforms and found out that the root cause of these issues is a bit deeper. The programming platforms offer some security-sensitive features that lead to vulnerabilities and enable the development of custom targeted malware that won't be detected by traditional scanners. Automation scripts are an overlooked attack vector that should be treated and managed like any other regular software. In our paper, we describe the details of our findings and suggest short and long-term mitigations for control process engineers, system integrators, and OEMs.